Hello, I am Caleb Jensen, and this is the Learning from Learning, a tale of two agents. The goal of this project is to study what's called meta-learning, or learning to learn. To explore this topic, I will be running experiments on the Cartpole gym environment. In many assignments for this class, we've manually changed the hyperparameters in environments to see how it alters the results. We need something that can do this better. We can use a reinforcement learning agent to handle this, and tap into the field of machine learning called meta-learning to help. This is when a machine learning agent is used to assist and learn from the results of another machine learning agent, hence the meta part of the name. The system will be set up like such. The agent is a meta agent that I designed. It will utilize a simple Q-learning algorithm to learn from the environment and the rewards it's given. The environment will be the Cartpole gym environment, which will utilize its own neural network to learn from. The actions the system will take is altering the 6 hyperparameters of the environment: decay, randomness, minimum randomness, learning rate, neural network layers, and batching memory size. The rewards given to the agent to learn from will be how quickly the environment can reach its maximum amount of steps and how many times it reaches that maximum. The agent begins with a range for these 6 before mentioned hyperparameters. For the base case of the simulation, it will use the exact middle of these ranges for the hyperparameters. Then, on the first step of the experimental phase, it will take a random action since it has nothing to learn from yet. After this point, it will use a Q-learning algorithm to determine which direction to take the hyperparameters at each step. The agent has a linearly decreasing control over how much it can alter the hyperparameters to help it fine-tune its selections by the end. There were countless simulations run to test this process leading up to the ultimate final simulation. It consisted of 1 base case simulation and then 8 follow-up experimental simulations. The base case and experimental simulations were each ran 10 times, and the results of those were averaged out before moving on to the next steps. Within every iteration of the simulation, the Cartpole environment was ran 1,000 times. This means the Cartpole simulation was ran 90,000 times, for a runtime of around 2 hours. This high number of iteration ran allows me to have confidence in the results. This ultimate final simulation was a success. After taking a couple iterations to learn, it was able to improve the simulation on all fields that I was tracking it on. This includes the average amount of steps Cartpole was able to reach and how many times it reached its maximum steps. Here, on the table on the bottom right, is the best hyperparameters the meta agent was able to find for the Cartpole simulation. In conclusion, my meta agent was able to improve the Cartpole simulation every time the experiment was ran, with the best results coming from this final ultimate simulation. I would rate this experience and experiment a success. It was generalized enough that it could easily be implemented with other gym environments, which I plan on trying on my own in the future.